Hi, I hope I'm audible. Yeah. So I know this is last workshop and we have been here for some time now. So I hope my talk is not, I won't let you do too much of work. So there is some hands-on part, but it's fine. It's just like git checkout through a bunch of branches. So yeah, you can just chill and relax. Don't relax so much that you just end up sleeping, but yeah, you can relax. So before I even start, yeah. Does can anyone guess which company owns this product? Yeah. And we know that so well because Google has defined a certain level of visual language to it. There's a look and feel to Google products that just tell us that this is Google and the other thing is not. And visual language is one term to remember. Second thing is, it's the visual language gets repeated multiple times. So it gets repeated in Excel sheets, docs, slides, and a lot of similar Google products. What that does is it brings a visual consistency. And beyond that, what it does for users is, I know how to share, I know how to switch profiles, I know how to save something, export something, without even knowing what that product is. So if Google launches a new product tomorrow, I already know how to use like half of that product without even knowing what that product does. And that takes us to visual consistency. So visual language, visual consistency. Then let's say we have this UI to build. There's a side nav that see. There's cards, there's chart. There's like some select input as well. Normally, if we want to build this UI, it can take around 3 days. I know this because I asked ChatGPT, and ChatGPT is the best developer. But that's because we have to rebuild a lot of these things. We're rebuilding a chart, we're rebuilding the side nav, we are rebuilding the cards. But if you already get these components out of the box, the time will reduce by quite a lot. And these components are not just visual, but also functional. For example, chart can come up with its actual chart things where you can hover and do things, or select input will come up with its own options and different way to define on-change values and all. This can bring the speed down to somewhat around 2 hours, or like half a day at least. And that's our third point, shipping fast without breaking things. So we want to ship fast, but we also don't want to break things. So we know visual language, we know visual consistency, we know shipping fast. Let's see what design system is. That's what my talk is about. Design system is a central place to manage visual language, visual consistency while shipping fast. So it defines a visual language for your company. It makes sure that the visual language is repeated multiple times so that it brings the visual consistency in different products of your company. And it does so by making you ship things fast, because there's similar solution for all of these things. Reusability is the solution for all of these. If you have something reusable, you already by default make things visually consistent. If it's reusable, you ship things fast. If it's reusable, you already end up defining a visual language. So yeah, that's what design system is, and that's what my workshop is about. And visual design system is a standard, and there's this funny meme about the standards where when you try to define a standard, it just ends up being like a 15th standard. And the talk is actually not about just design systems, but how do you make sure that our standard scales so well that it doesn't end up becoming a 15th standard between a lot of the standards. So yeah, that's what the workshop is, design system for scales. We'll talk about tokens, components, we'll talk about motion, and we'll talk about some of the AI tools as well. I'm Saurabh. I work as a lead front-end engineer at Razorpay. I work in the design system team of Razorpay. We've been doing a lot of AI things. We've been building design system for quite a long. And yeah, this is something, I'll show you some Razorpay examples as well, and we'll see. This is what I talked about, the central place to define visual language, visual consistency, and shipping fast. This is still a very product definition, maybe not very hard to understand for devs. So what do I mean this in the dev terms? It's set of tokens, components, patterns, motion presets, UI guidelines, plugins, AI tool, anything and everything that helps us define this visual language, that helps us define this visual consistency, and that helps us ship fast. We talked about what is a design system. Now I'm going to play a game. I'm going to show you different pieces of code, different images. You have to tell me if that's a design system or not. Is this a design system? Is it? Okay, some yes, some no. No? Okay, no. That's because we are defining the same color, but the devs can go and change the color. We can't really make sure that the colors stay constant. But what if the devs promise each other that they don't change the color? Is there a design system then? Is it? Yeah, it's still not, because someone can leave the company, one friend can betray the other, so we don't really know if they'll be able to maintain the sync or not. Is this a design system or not? We're using some CSS variables here. We're defining buttons. Is this a design system? Okay, mix of yes and no, and that's kind of what the answer is. This is where it kind of gets into the gray area. We are defining the visual consistency on the token level. So we have the visually consistent colors, we have the visually consistent font sizes, but still I can go and define a different token to a button. I can still build two different buttons which look very inconsistent. So although it defines the visual consistency on the token level, it doesn't define it on the component level. Is this a design system or not? Yeah. Yeah, it is. So in this case, we are defining component. We are encapsulating a lot of components decisions into a single component. So I can go and use this button at different places, and it will have the same color, it will have the same feeling, it will have the same hover styling, same focus styling, and everything. So yeah, it's a design system. Are these design systems or not? How many of you believe that both of these are design systems? Few people. Okay. How many of you believe that one of these is design system? Okay. More people. How many of you believe that none of these are design systems? Okay. Very few people actually. This is what Material UI says in the documentation. Material UI is an open source React component library that implements Google's material design. So Google's material design is a design system, but MUI in itself is still something that they define as a React component library. MUI in itself won't be enough for you to define a visual language or a visual consistency for your company. You can build a design system on top of this. So this can be a base for your design system, but MUI itself is not. Or it's still something that falls in a gray area, but largely it's not a design system because it won't be able to bring that consistency for you. Similar with Chakra. Chakra says that they're a component system. They still don't use the design system term because similar as MUI, you can use Chakra UI as a base and build design system on top of that. But Chakra in itself is still something that calls it a component system. Is this a design system? I have a CDN diagram with FP. Yeah. That's a system design. That's nothing to do with design system. If you have a system design interview coming up and you tell them tokens, components, you're probably failing that. Although it is part, like I can technically call my talk system designing the design system because it's still a part of system design, but largely the topics are unrelated and nothing to do with each other. So yeah, I have some hands-on part. If you have laptops, you can go to this URL, git clone the repo that you see, just cd to it, and if you have pnpm installed, you can just install the pnpm. It's just git.new/ds workshop. I shortened the URL. Is it done? Yeah. Let me check. I'll just give the actual link. There's the actual link, so you can open this directly as well. Yeah. Okay.
There is conference 5G.
I just connected my hotspot.
No, no, no. It is really very fast. Conference 5G.
Conferences.
5G, 5G. This one, this one. They have password. Let me just get it. Sir. Very fast. 9 password. 90.
90. It's not connected.
This are a features here.
Okay. Yeah, I'll reload this first. Yeah. Yeah, this was the actual link. Was everyone able to get cloned? Okay. So yeah, what I'll just open that link as well. So what I have here is just the GitHub repository with some boilerplate code. It's bundling setup. We'll go through that and I'll explain what that boilerplate is. In branches, I have different steps. We'll just check out through the steps. I'll still write some code and explain the parts, but yeah, we don't have to write much of a code. We can just check out through the steps to understand how each step is building the design system. There is also some README to explain what each step does, but don't read that. That's a spoiler. Yeah. So yeah, I already have this it checkout. I'll just increase the font size. Cool. What I'll do is I'll just explain you what the code is and what it does. You probably won't see this package. Yeah, there's two packages, app and Nexus library. Do I change the theme? Okay, I have to do this now. Nothing makes sense to me anymore. Sure, we have app and Nexus library package. App package is just the create read apps initial boilerplate. I've removed some of the code from there, but this is something that we don't have to care much about. This is going to be the demo application which will run our design system. Nexus library is the part where we'll actually build the design system and write code. This is because I was doing git checkout. You probably won't see this. Yeah, you probably have the README file. Before we even get started, what I'll do is I'll just create like one index.js file. How many of you here have built an NPM package, by the way, built and published? Okay, nice, decent amount. Cool. So I'll just explain you the setup and then we can go into this. What I'm doing is I'm just writing like an add function that adds two numbers. And what I'll do is I'll just create a package.json here that has some name, which is like a library name version. Sure. I'll just remove a lot of this boilerplate. We don't need this right now. And I can create like a exports file, which will point to our index.js. So what I'm saying here is whenever a library called this is imported, just go and check this URL. I'll also define it as type module so that we can write the ES6. If you're building libraries now, it's fine to have it as type module. Most libraries are ESM now. Now, here's a fun thing that we'll do. We'll try to install this local library into our app package. What I have here is a PNPM workspace. What PNPM workspace does is it lets you define multiple packages in your packages directory or any directory, and these two packages can talk to each other. So that is what we'll do. I have an add function. I'm going to do something like Nexus library. And in PNPM workspace, you can run command on a certain package with filter. So I'm asking it to run it on filter app. And I'm saying that don't look for this package on NPM, just look for this in the workspace. So -- workspace will do that. And yeah, I'll just install this. Cool. What we have is, you'll see this in your package if you run this. So you can actually, yeah, we'll actually see this in the next part as well. But what I'm doing here is Nexus library is now installed locally from this. And I can go to my app.ts and I can say import Nexus library. And I can import a add function from here. And yeah, I can just define it here. And you can run your application with PNPM dev app. Yeah, what you see is, okay. You'll just see this output. What we're doing is we're just importing the add library and we're running that add library here. It's fine if you're not able to follow up as well. I anyways have this code defined, and I guess most of this code can be generated with AI now, so you can ask AI to just give you a command to install the local library. It's fine. We'll mostly talk about the architectural parts. So yeah, we have this local thing running. Let's do fun thing. This is just like very local. This is very simple function. Let's try to run a React, like a React component in this. I'll still keep it as index.js. What I'll do here though is I'll try to write some React code. So I can say text component. And this. We see an error here because the library is still exporting .js. I can technically fix this error by defining it as JSX because it's sweet. So it will be able to understand that it's JSX and pass it. But if you're deploying it as a library, publishing it as a library, what you need is a way to bundle the code and actually make it React. So if you have ever run npm run build over your React application, the output you'll see there is something like this, where you'll see some JSX coming from JSX runtime and a div here. And we see the code is working fine. Let's actually try to import text now. And here I can go and change the text. And it's sort of like a React component working in this, but what we're writing is we're writing the code that React outputs. We don't want to write this, unless like you're a really weird person, you can still build the entire applications with this, but you probably don't want to do that. So what we want to do is we want to have like some bundling setup that bundles the application for us and gives this as an output so that we can write the code that we write using JSX and still get the output that we want. What I'll do is I'll just git stash things have done. Yeah, that's fine. We can go to step. We can get checkout to the step 2. So if you have in your machines, you can just git checkout to step 2 to get to the next part of this. Once you git checkout, just run pnpm install on your root once so that it will install the new libraries that are there in that branch. Okay. Sure. Yeah, works, because the thing is, the code gets really large at some point where it becomes difficult to follow up. So it will take too much of time if we start following up. But what I have is in the repository, in the README, I've mentioned what each step does. So you can still follow it up along later, yeah, if that is fine. Otherwise, it will just end up taking too much time on this part. We can move to the next parts. In step 2, what I have is some initial bundling setup. So now I'm actually writing React code like normal people, where we have like JSX defined and we can have like text component defined. We can define everything the way we define in the React components. The only thing that is changing here is like some ts config, and I have this read config.ts file. This does few things. So let's just go through this one by one and see what it is doing. The React plugin, the Vue.js plugin React, it will just help you convert your JSX to your normal React applications. So the reason why we are not writing that JSX things anymore is because of this plugin. This plugin is doing the internal conversions. There's a DTS plugin. What it does is generates the types. So earlier, you might have seen that there was a TS error here, which is still there, because I don't think so I've run the npm install. I'll check that. But yeah, there was a TS error which should ideally be gone. We are defining the types here in the exports, which says that from where to go and pick the TypeScript files. And then we have some build configuration. So normally if you build Vue applications, you would see that index.html file is there, which becomes your entry point by default in normal Vue apps. But in this case, our entry point is not a HTML, it's a JavaScript file, because we want to bundle the JavaScript into something that libraries or the consumer apps understand. So that is kind of what this part is doing, where it's just taking your entry file, it's defining that I want the ESM output, and it's just giving you output in this out directory. I've set to minify false so that we can read the code that it generates as well. And external is a concept where, let's say I don't mark this as external. What Vue will think that because I'm importing React in my library, it will try to put React's bundle in my library as well. But what we want is we don't want React to be shipped along with the library. We want React to be a peer dependency of your consumer applications. So in the package.json, I've defined the React as a peer dependency. We don't want it to be bundled. And every time you define a peer dependency, it's most likely that you would want to mark it as an external as well, so that it doesn't get bundled, and it will use the React of your consumer applications. This is something that I personally prefer, where I try to keep preserve modules. I'll tell you what it does. Let's just run the build command once. Yeah, we've built application, and this is the build output. This is similar to what we wrote initially, but we're writing JSX now, and this is what it gets output. And we have a TypeScript file. I didn't run npm run build. That is why it was showing the TS error earlier. But yeah, this just creates like TypeScript files for the library. What preserve module does now is it maintains your file system that you've written in the SRC. So let's say I go and write some button component here in a like a folder, and I define like different files there, and then I run npm run build on it. It will still maintain that in the dist. This is just something that helps you, like it's unnecessary to bundle everything into single file if you're building a library, because anyways your consumer application will take care of that bundle. So this just lets you debug more easily in the dist. If you don't do that, if you define 100 files in a library, it will become one file in your dist. Cool. So what we have here is a text component. In your app.tsx, we're using text, and it's still, I can still define the text component as a JSX and use it here. We can run the dev app. And we have this running. So in your branch, I haven't really made any code change here. So you can also do these steps where you can just run cd to packages, Nexus library, run pnpm run build, and then you can run from your root, you can just run the pnpm dev app. This will run the dev application. So yeah, if you want to follow me, you can try these steps. Is it working for everyone? Good. Cool. The third part we have is implementation of style components. How many of you are using style components at your work? So one thing about style components is it's under maintenance now. So I was actually exploring different libraries. So at least at Razorpay, we're still using style components, but I was exploring different libraries for this particular demo itself. I couldn't really make any opinion on that yet. And anyways, I just want to talk about the architectural parts in this demo. I don't want to go too much into library decisions and everything. So everything that we talk about still applies in both, in whichever library that you use. So yeah, for this demo, I'm still using the style components. We can git checkout to step 3, which has some style components set up. You can still do the pnpm install. This will just update any new libraries that we have added. So a few things that I've added in this particular branch is I've added a theme provider of style components. What it does is it just takes some theme tokens and passes it to the actual theme provider from style components. It's just a wrapper around theme provider. And I just have like simple button component, which just passes the on click to the actual element. This is the file that we're going to deal with. This is theme.ts. What it has is colors, and it has this light file and the dark key. We can go and define tokens in this, and that will just help us go to the next steps. So this is the demo where I'm going to pause, and we're going back to the slides from here. We'll just talk about tokens a bit more, and then we'll come back to the demo, and we can work on this demo. So yeah, we just have like basic token setup now. Let's talk about the token architecture. If you are building a design system, how do you architect your tokens? Like how do you define tokens? What all is needed? Um, we can have something like this. This is the actual color palette of Razorpay, where you have this azure color defined with different values, and then you can do this where you have button color azure 600 and then box background color azure 600. The problem with this is it's not exactly scalable because at some point if your let's say your brand color changes, now you're in a weird position where your like color like blue 500 is pointing to a red color, or let's say it's not changing brand color is still like very rare scenario, but let's say your shade shifts in color. In that case also you kind of end up breaking the consumer applications where people have defined the background color as azure 600 or yellow 500, and now you have to go to consumers and say that our brand color is changed this shade, so go and change in your applications, which can be a big breaking change. So this doesn't scale very well. I'll just talk about how the setup is at Razorpay, and then I'll just talk about what would be the ideal setup. So there's two types of tokens that we define. There's global tokens and semantic tokens. So we first talk about the global tokens. Global tokens are your global color palettes where you just have different color palettes defined as global palette. This becomes your source of truth for every single color that your org uses. Every single thing that you see is defined here. What we do is we kind of build an additional abstraction layer on top of this, which is called as semantic tokens. So you can have semantic tokens where you say my semantic token called surface.background.gray.subtle points to my global palette of neutral like 200, or my positive color points to this this color, or primary intense points to this color. And these are just examples. You can have tokens like surface.x.primary.normal, surface.border colors. So you can have different types of semantic tokens. These are just examples. The good part about this is now you can scale it for your different themes as well, because your semantic token can point to different color palettes, different colors in your color palettes. So your light can point to this neutral light 200, your dark can point to this neutral dark 1000. You can point to the same color palette with different shade. And in this case, the earlier scenario that we talked about doesn't happen, because if you go and change your brand colors, you just go and change your brand color palette and you still keep on pointing to the correct semantic token that you're expecting, and you don't end up breaking your consumer applications. Let's actually go back to the demo and try to implement this in the demo, and we'll see how we do. What I'll do is I'll just take a screenshot of this and ask AI to add this palette. Again, it's fine if you don't follow along to this part. At the end of the time, at the end of the demo, you'll probably have some color palette defined, which you can go and play around, change colors, and that can help you figure things out as well. What I'm doing here is I'm just asking it to haven't defined global colors here. At Razorpay, global colors are something that we don't even expose to consumers. So it's just something that we internally use in the design system. So there's no way to say background color Azure 500 at all. You can only use semantic tokens. So it just lets us guardrail what exactly the colors that are being used, and make sure that every color that is used has semantic meaning to it. Add these colors. Good. We have Azure colors. I'll also add the global color palette that we have, the gray one. Oh, it's too big. Cool. So I'm just going to use 2 color palettes right now, which means that the demo application that you see is going to end up looking bad because ideally you should have more global palettes, but we're just going to work with 2 colors for now. What I'll do is I'll just go and define some semantic colors. I won't define a lot of them, but just as much as I can use. Surface, background, primary. And I can just use the global token jar. Let's say 600 is our primary color. Now this becomes the primary of a background. We can also say some text color. So what I'll do is text on primary on intense. So this becomes the text color that gets applied on this background. I can actually define some more colors, we'll need them. I can define like a static white color. It's usually handy. Anyways, we don't expose these to consumers, so we can use these internally for defining anything. So yeah, I'll just define it as static white. Should look fine. It's a blue color with white text. We can define the same thing for dark colors, where let's just use a lighter shade now. So you're in dark theme, it can become a lighter shade. And then here I can use static black because it's a lighter shade. So yeah, we have global and we have some semantic colors defined. Let's just use these in our button component. What I'll do is style button. Yeah, thanks AI. It says background color, and I'm just importing it from style components. Yeah, let's just define a few more styles as well. I'm not doing anything. I'm just reading this code because I wrote this at 3 a.m. at night, so I'm not sure about this code yet. I'm exporting the button. Let's try and see if it's able to build. We'll go to C packages, Nexus library, pnpm build. Cool. It's able to build the component and the DS theme provider, and we can also try to see if our app is working with this or not. Yeah, cool. The app is working. In app, what I'm doing is I'm just wrapping that theme provider here. I'm defining color scheme as dark. I'm passing the theme tokens the theme that we created. So it's the same theme.ts file that we are exporting from here. I have this button definition in my app.tsx. If you see here, I'm not passing any color here. I'm not saying color scheme or anything. All of that is still controlled in the main.tsx. If I go and say color scheme light, it will go and change our button colors as well because we have defined the light and dark differently in our theme provider. So in the theme provider, if you see in color scheme, whenever color scheme changes, we switch the colors that are being used as well. And that just helps us control different colors and tokens. So yeah, we'll just go back to slides. We talked about colors. We can just briefly talk about spacings and elevations. We don't have to go too much into deep of that because these are not fun. Colors are fun. Spacings and elevations are mostly like straightforward. They don't have, we don't define global and semantic tokens in this aspect. Although you can do that. So you can say that my global palette is 24 pixel, 12 pixel, 4 pixel, and your semantic token is something like button.padding, but we don't really need to do that. I think that it's fine for us to just say that button padding is spacing 5. It's anyways defined internally for us, and we define for spacings, elevations, border radius. We also have it defined for a lot of other things as well. We also have motion tokens defined, easings, like the easing curves defined. There's one thing that we didn't talk about, which is white labeling, where I have defined like a blue color here, but white labeling is when you want to change different colors. So I'll actually go to this link and show you the demo as well. If you want to try it out, just scan this. You'll land on a like a blade.razorpay.com, which is our documentation for design system. It has a white labeling page there. Cool. So this is the page that you would land on, where we have a theme defined, where the default theme is this blue color theme. I can go and switch themes. I can go and say orange. I can define it as red. I can change it to different. I can even select like some value. Every theme has a light and dark because in the theme tokens we said colors as light and dark separately. Now, here's an easy part and difficult part. The easy part is setting the primary color because we already know we can get it from the create theme, where in the create theme you can just define this color, where I have this brand color defined, and I can just take that and put that in my primary token, and that's done. Here's the difficult part. We have to change other colors as well. For example, if you see hover here, the hover is not exactly primary color. It's like a subtle version of that primary color. Similar thing happens with this button hover as well. This is like darker version of the primary color. Now, how do you do this in your design system? Like, how does a token architecture scale to something like this? We talked about this global palette. We have this one global palette defined in our token architecture now. We also know that the primary semantic somewhat points to this Azure 600 or Azure 500. With create theme, we get one more color, which we can say that our semantic primary token now points to this new color now. What we do is we actually generate 6 shades lighter than that color and 4 shades darker than that color. And we just set that on the global token itself. And to do this, like finding 6 shades lighter or darker, there's also like a complex math that you can use with HSLA, or you can just use some libraries that let you do this. And you can just adjust your scale according to how it looks visually. The good part about the global token palette now is without this, what you would have to do is you would have to go and put a bunch of if-else conditions in a bunch of your components, say that if color is different, then maybe use like a lighter shade, or if the color is other one, or use a light darker shade. But because you've defined this global tokens and we've also defined semantic tokens, the semantic tokens end up pointing to the right global palette, so that you can change the global palette and still have your applications working. And that sort of solves like 90% of your scenarios. And 10% scenarios is where you'll have to change the semantic token, still not something that consumers have to put if-else conditions on. And that's kind of how this white labeling that I showed ends up working. Let's talk a bit about components architecture now. I think tokens was like the biggest part. Once you have like a good token scale defined, it solves a lot of your problems. So let's talk about component APIs. What I mean by component APIs, first of all, component APIs are component APIs are where you define how you expose the component. For example, if you're exporting a button component, you say that variant, you define that variant is the prop that you want to use, or color is the prop that you want to use, what values the color has. Yeah, I don't have much demos from here, so I can stand here. Component APIs is where you just define how you want to expose your component to your users. This is like a simple component API where you just have a button, I'm saying variant primary, color white, and I'm defining on-click. Let's talk about something like tabs. Tabs can get a bit complex, where I have this config-based API, And I have this JSX-based API, and we want to decide which one we want to go ahead with. We'll talk about this a bit more, but this is what API decision is, where you decide which API you want to go ahead with. Now, we're going to try and use our intuitions and guess the API. So I'm just going to give you some examples, and then you have to guess the third example. I have this alert that looks like this. It actually has a green background that is not visible here much, but it has this subtle green background. So I'm saying color positive and emphasis as subtle, which makes the alert subtle. I can say color positive and I can say emphasis as intense, which makes this intense alert. Can someone guess what API this component has? What would be the first prop? Yeah. So yeah, we'll have color and we can say negative. And what would be the second prop? Yeah, emphasis subtle. Now, you've never seen batch component code before. I've just showed you alert components code. Now, based on the alert components code, you're able to guess what the code would be for batch component. And that's because all of us have some intuitions on what we expect from our API, where you're seeing the component visually, and from visual sense, you're trying to guess what the API would look like. And that's kind of what is important factor in defining the APIs of components. Let's talk about something like this. So we just talked about props, but it also applies to the anatomy. For example, I have this card. I'm defining card header, card body. I have modal. I'm defining modal header, modal body, modal footer. Same with drawer. I'm defining drawer header, drawer body. It's not just about props, but it also applies to the structure of your components and how you expose these components. Let's go back to the tabs example. I didn't tell you which example is actually the better one. This is something that we prefer in Razorpay at least. And the reason is, this is like a larger section of a tabs code. I can just give you like 1 minute to read through this code. So Anurag from my team, who by the way, I think you might know him from Twitter. He has built the GitHub README stats. He does a lot of TypeScript things. He actually put this diagram in one of his tabs API. He's the one to do the tabs API decision, where he said that the reason he wants to go ahead with this type of API because it matches the visual hierarchy of the component, where the tab panels match what it visually looks in the UI, where in the visual UI, I can see there's a tab panel here with some tab items, and there's the tab list there, and then at the bottom I have tab panel. So your code sort of matches the visual hierarchy, which again takes us back to the badge example, where from the visual sense, where the badge was subtle and it had a red color, from that we just guessed what the props are. So from this we can guess what the anatomy is, basis of the visual structure, visual hierarchy of the component. And that's why we go with that, that type of APIs usually. This is one example of our SideNav API. I'll just show you here, where this is how we write API decisions, where it's just a markdown file with a bunch of images and how we want to expose the component or not. This is a larger sort of component where we have the SideNav, we have SideNav body, SideNav link. Again, similar structure as drawer. We have different SideNav levels because we have multiple level SideNavs. And there are some alternate APIs where we figured out, we tried out this config-driven API as well, but again, for a similar reason where it doesn't match the visual hierarchy, we end up going with JSX sort of APIs. And there's like different examples. Again, this is open source, so if you go to Blade repository and go to any component, you'll see a decisions.md file where you can see why we took that particular decision. Now, we have tokens and components are enough to get the application working, but is just working application enough? At some point, you want to go and give that delight to your consumers where your application does more than just working. It's sort of like sprinkling salt over your applications, or like the cherry on the cake or the pineapple on the pizza. Yeah, we're not talking about that. And it's coming. Yeah. Motion. yeah, motion is the delight that we figured out, where motion is like a step one of delight. It kind of does something that users don't expect your application to do. And I'll just talk briefly about how we define the motion and what exactly we do here. This is example of one of the what the motion does, where we have this card where it just staggers and comes from the bottom. Now, what are exactly the goals of the motion? This is how we defined as goals: ease of use and fast and performant. The reason why I would put ease of use is because it's not making your app functional or non-functional. So if it's difficult to do for your consumers, they might just not do it, and they might end up skipping it. So it has to be really, really easy to implement motion. The bar is a bit higher here for APIs compared to components. And it has to be fast and performant. You don't want your end user applications to lag. In ease of use, there's a term called as enhancer components. How many of you have heard of enhancer components? Oh, nice, good topic for me. Enhancer components are where you have a component that doesn't really render anything on the HTML. For example, I have this example where I have a fade component and a card component inside of that, and it renders just one div with the same card component. The fade in itself is not rendering anything on the HTML. So what enhancer components do is they just enhance the inner child and add things to the inner children. So this doesn't end up being part of your layouts. I can change this fade card to something like button, and it will still fade the button. So I don't have to go and change the code of the button now to add the fade to it. I can just have a fade component that works with everything. So I have a fade with card in it. I can do the same thing with button. I can do the same thing with alert. I don't have to go and add a fade animation to every single component now. Just like fade, I can do other things as well, like move card. We have a slide card. So you can go and define animations that work with every component, and it's sort of consistent with how you visually see. Again, going back to the visual hierarchy point, where you would visually think of a component as it's something that's fading in. So your fade is still like something that we add as a wrapper. So this was just like singular animations where you have fade, move, or slide. So this is kind of how fade would work. But you can also have stagger, where you can put the same fade component into a stagger component, and it sort of staggers. It creates that stagger experience. And that's about API. Let's talk about the performance part once. I actually have a demo for performance part where I have it on Code Sandbox. So let's not care about the code part for now. Let's talk about this. I have these two divs which just rotate and move. And what I'm going to do is block my thread. If you notice, the GPU one is still working and the JS one is still getting blocked. So what exactly is this GPU one doing differently that's not blocking the animation when main thread is blocked? And this sort of ends up creating smoother experiences eventually, because your JS main thread is not blocking the animations anymore. So there's a concept called as, there's an internal API that web provides called Web Animations API. What Web Animations API does is it sort of exposes the browser's internal animation things to consumers. It uses the same, so your CSS transitions, if you've seen, this same thing applies to CSS transitions as well, where CSS transitions don't get blocked by main thread. Web Animations API exposes the same part of it to JS as well, where you can run animations without really making it while they're smoother. Although there's a limitation to this, where it only works with some props. There are some props which are GPU accelerated. So transform prop, for example, is like a major one that will help you do most of your animations. That is GPU accelerated. This is also something that we use in our motion presets part. Then opacity is the one that is another that is GPU accelerated. But if you go and put top 100% in your component, it's going to break. It's not going to run on GPU, it's going to run on the CPU part. In most cases, you probably won't have to care about Web Animations API, because if you're using a library like Frame Motion, which is, by the way, called as Motion React now, if you're using that library, Frame Motion internally handles this. So if you pass a transform value to frame of motion, it won't really block your main thread. So the demo that I had was actually on the frame of motion, where I am defining transform on this GPU block, where I'm just saying that transform 300 pixel and rotate it. And here, on the other hand, I'm defining them as like separate properties rather than transform, which makes it run on the GPU. Frame of motion also uses this will change property that CSS has, which lets the browser know that something is going to animate. Yeah, there is this link. You can actually just search for motion or traceapp in Google as well, and you'll see a documentation for that. I'll probably skip that because it's anyway I've seen showed the demo. Now this is something. Okay, the motion part is done. This is something that I showed initially when I was in the beginning of my talk, where we have a components and that helps us ship faster. But what if we could ship further fast, where you just build something in like, let's say 15 minutes. Now, how do you do that? And if you could actually achieve that, you end up saving so much time that you can use in very valuable things in your life, like watching cat reels on Instagram. This is the most invested I've seen this audience. This one is my favorite. Yeah, we're going to watch the full thing. Everyone's looking at me. Okay, yeah, that's it. So yeah, back to the topic, AI. AI helps us ship in 15 minutes. How does AI do that? There's something called as MCP server. I think Chaitanya from my team talked about it yesterday. We have an MCP server that just helps us give the context of design system to different AI tools. But let's see what that even means. If you go and ask your ChatGPT what is MCP server, it says that it's Minecraft mod coder pack, which is fun thing about AI. It's changing so fast that the AI models themselves are not able to keep up. ChatGPT doesn't know what MCP is. So what exactly are the MCP servers? Let's say you write this in your AI tool. You say, hey AI, add 3 to 4. That's an English prompt now. But what you want to do is you want to execute something when this prompt comes. And there's no standard way to say that when a prompt looks like this, maybe execute this function. And MCP kind of comes in and introduces that standard. So you have a English language which AI tools understand. MCP ends up acting as a layer which exposes different tools, and it can, depending on which tool it feels it needs to call, depending on the description of these tools, depending on the names of these tools, it can actually run functions. It's a very simple thing, but what it allows you to do is it allows you to run actual coding things, the things that we have defined in functions, the things that we normally write, the things that we build, to MCP. We expose our libraries to AI language. I kind of have this demo. Who all were there at Chaitanya's talk yesterday? Okay, good amount of people. So I think it's a similar demo. It's actually the same demo, yeah. So we have this Blade MCP. It's published as an NPM package. I can go and copy the MCP's configuration, put that in cursor settings. I have this MCP installed now. It's exposing different tools. I can go and say, this is just Hybrid tool that tells you what all MCP can do. Let's say I go and tell MCP, hey AI, build me a dashboard. So yeah, I'm just asking it to create like a simple dashboard, keep the main area empty. It's making some tool calls. First tool call was the create cursor rules, which just creates the cursor rules. And then it scaffolds the project in your repository. So the files you see, they're actually scaffolded by the MCP tool call now. Then you have this tool call for getting the documentation of your design system components. It yeah, it just return the documentation. It'll try to fix some errors. It'll figure out that, okay, this code is fine. It'll try to run the server. And we have this dashboard here, which is running. We have like a simple dashboard, which is showing like main content area. It added side nav, top nav. It used the documentation examples. And you can also convert Figma to code, which is something that Chaitanya talked about in depth, where I can go and select, like, copy a frame link from Figma. I can paste that in my chat. From the Figma link, it picks the frame node and the URL of the Figma, and it makes the Figma API call, which actually gets the frame nodes, and it can use that for building the AI things. So you might have seen there's a get Figma to code tool call, which is what turns the Figma URL to the code. And we have the Figma node that we selected as a code now in the UI. We can go a step forward. We can try to make things functional now. I'm just adding a heading here because I saw that page and I was like, oh, there's no heading to this. I need to add, otherwise it is just looking weird. So yeah, this is just something that it added the heading. We can try to make this button functional. There's this add functionality button. Now what I'm just telling the AI to do is just check, just make that button functional and add some creation flow view to that creates like a stepped progress form. It actually fetched the patterns this time, not the components, because it understands that the pattern is something that is needed here. It's a larger pattern, not just like a singular component. And from the patterns, it can also fetch which components are needed for that pattern. And it generates that step form. It also makes it functional. It also added the step group, which actually changes when you move to the next line. It did some validations. And the way, so yeah, there's a preview, but the way we do that is we just expose the AI understands what style component is, AI understands what React is, AI understands what Tailwind is. What it doesn't understand is what your internal design system is, what your internal design system's components are, what they expose. And we just have an MCP server that acts as that middle layer that just exposes that information whenever it sees like a relevant prompt from AI. And yeah, we have this application working now, which has side nav, top nav, some Figma URL that we copied. You can give prompts, you can give Figma, you can give combination of prompts and Figma. And yeah, that's it. Yeah, that was my workshop.